So one more time, we're going to talk about characteristics of graphs here. And one of those is whether a graph is symmetric. What does it mean to be symmetric to something? Identical to? Okay, but it mirrors itself across what? Symmetry can be across a line or across a point. Okay, and so you've probably looked at symmetry many times over the years. In our case, there are three things we can be symmetric to on a graph. What would be two obvious things, two lines we could be symmetric to on a graph? Yeah, it would only be logical sense. So you can have x-axis symmetry, you can have y-axis symmetry, or what point might we want to be symmetric to? The origin, yes. So, three kinds of symmetry, and once we look at this a second, it's actually really easy to test for this. But let me draw you a couple pictures here.
We learned this yet?
No, you have not learned this before. So, would you say that graph that's symmetric to the x-axis?
No.
Am I mirroring on either side?
No.
Okay, you can't be super. I can't draw a letter perfect.
Yeah, sure. You want it to be. Yeah, sure.
It's supposed to be, all right. It's mirrored across the x-axis. So if this coordinate is xy, what would be its mirror coordinate?
Y negative x negative y.
Which way? Okay, I've got negative xy and I got x negative y. I would still be over x, wouldn't I be the same? But I am down y this time. So the y coordinate changes.
Yeah.
I didn't leave myself enough space here.
Why didn't you just draw straight lines on that?
Because she wanted us to be as straight as Cody.
It does look like a
Okay, y-axis symmetry. If I do something like that, to be symmetric to the y-axis, where would I have to draw? I would have to draw on.
I don't know for sure.
Okay, so this time, notice what would change about the coordinates. If the one in the first quadrant is xy, this is negative x, but still positive y. Okay, then last but not least, if I do origin, and I do something like that, to come across the origin, I have to reflect into the third quadrant. So yeah, I have to do something like that. Okay, so now think about those coordinates. If this is xy, what's its mirror down here? Yes, they are both negative. Negative x and negative y. Okay, because of that mirroring, that actually is how we're going to test it. Obviously, if I give you a graph to look at, you can spot with your eyes whether it's symmetric to the x, y, or the origin. But I want to be able to give you an equation and have you tell me whether the graph would be symmetric. Now, are all graphs symmetric to something? Every graph you drew on your assignment was symmetric to the x, the y, or the origin. No. Once we shift them and all that, they're rarely. This does. In fact, it's kind of a special case, but when it does happen, it can certainly help us with a graph when we know we have symmetry. Okay, so how do you check it? If I actually give you an equation, such as y equals 2x squared plus 1, and I say, is that graph symmetric to the x-axis, the y-axis, the origin, or nothing? Might not be symmetric to anything. How are we going to check it? Well, it turns out, since it's the y-coordinates that change on an x-axis symmetry, when you're checking for x-axis symmetry, you're going to sub in a negative y. And then I'll talk about what happens in a second. What do you suppose on y-axis symmetry you're going to do? What's changing here? We're going to sub in a negative x. And on origin symmetry, we're going to sub in both. Yes, exactly. Now, what has to happen if it has that symmetry? When you sub it in, the equation will turn out, once you simplify it, they'll come back to what you started with. So if you can sub that in and then your equation turns back into its original problem, it had that kind of symmetry. So on all of them, it must change back to the original function.
Yeah.
Do I need to referee? Okay, we're doing the math. Okay, so x-axis symmetry, what am I subbing in? I said sub in a negative y, so you are literally, in place of every y you see, you're putting in a negative y. So if I replace that y with a negative y, I don't change the x's. Okay, did I get the original equation back that I started with? Is this the exact same equation? No. So therefore, that's not the same. It's not got x-axis symmetry. Okay, so on y-axis symmetry, what am I subbing in? You're subbing in negative x. So only in the x's, I would come here to this and go, oh, in place of that x, I'm putting negative x, but then I'm supposed to square it and add 1.
Yes.
Will I get the same thing back I started with?
Yeah, sure.
Yeah. I'll get 2x squared plus 1. That's the original equation. So yes, this one has y-axis symmetry.
What did you do there?
Yeah.
You did like no math.
I subbed a negative x in there. What happens when I square a negative x?
Oh, you get
You get positive again.
I see.
So I got the same thing back that I started with.
So how was the other one, no?
So the other one I subbed in a negative y,
So what did it change back to?
and there's no way it changes back to the original, so it doesn't work.
Put in a negative number.
Okay, so now try origin. You're supposed to sub in both variables negative. So if I sub in a negative y, and in place of x, I would get a negative x, which I square. So yeah, the y is not going to change, but the x is going to change back to positive x squared. Okay, so in this case, you would say this one has just y-axis symmetry. We know when we draw this graph that if we draw it on the right side of the y-axis, it'll be the exact same graph on the left side. And let me point out to you, this is a simple one. What graph is this? A line. Not a line.
No,
That's a parabola. Shifted where?
it went
That's a parabola shifted up one,
narrower.
and it's narrower. So it's basically doing something like that. Does it have y-axis symmetry? Is it balanced on either side of the y-axis? Yeah. It came out right. That's what it should have. Okay, let me have you try another one of those. Give me some space. We'll do something with a little more pizzazz in it.
Cody, shut up when we come over there.
Okay, so this is not a graph we know. We have not graphed things that have x, y's in them at this point.
Yeah, let's see it.
You gotta get the Y out.
Not right now am I going to graph it for you. I just want you to tell me about symmetry. So how do I check it for x-axis symmetry? I sub in a negative y. Because I'm going to have a 4, an x, a negative y. I'm not changing any of the x's. And when I simplify that, is the negative going to go away? No, it's just going to go out front. But it's not going away, so I didn't get the same thing back, so that's a no. You will soon get very good at spotting these coming at you. Okay, I already had somebody back here who said this is going to be origin. Why is it not going to be y-axis?
Well, if it's not y-axis, it's not going to be origin.
If I sub in a negative x for every x I see,
they said they was going to kill me if I didn't.
and so, okay, I pulled the negative out front here. Here the negative went away since I squared it. Is that the same thing I started with? No. So Caleb, is your argument if both of these are no, there's no way origin can work?
Yeah. I'll fight you for it.
Well,
He's wrong, but I'm wrong, ain't I?
if I sub in negative x and negative y, what's going to happen here? you're going to get the double negative.
Negative makes positive.
And so that will be a positive 4xy.
Dang it. Thank you, you were right.
Okay. However, I will give you this much. For origin to work,
Both of them have to be either true or not true.
yes, x and y have to either both be no's or both be yeses for origin to work. If you get a yes, no, or a no, yes on the first two, origin is not going to work. But if these two are the same, then origin is possible. Now, it is possible to have them all be no's. Might not be symmetric to anything. That's possible too. So, okay, is that, we get the gist of symmetry?
Yes. That sounds like a funny word that I once knew.
Okay, now, this next topic goes right with it. The two are tied together. Okay, now I'm talking even and odd functions. Let me take you back a second. When we do all these symmetries, are they all going to pass the vertical line test?
Yeah. Yes. No. The top one will not.
Yeah, x-axis is not a function. X-axis symmetry is not a function. Y and origin are going to be functions. So now I'm coming over here and I want to worry about what we call even and odd functions. Notice the word function. So these have to pass the vertical line test.
Function.
So therefore these cannot be x-axis symmetry.
It does have a negative voice, but now he's asking me if I want to function.
Caleb, you realize that this is on
Sorry.
recording.
I forgot we're being recorded.
Okay, I'm going to give you the definition of these, and then I want you to tell me how it relates to symmetry.
No, I don't.
Okay. Since we are doing even and odd functions, we're going to use the function notation, and you're going to discover this is extremely similar to symmetry. You're going to sub a negative x in, and if you sub a negative x in, Devin, if you want to sit, there's a desk. Can you see?
You don't need to see. He doesn't have glasses on. He can't see anyway.
I don't do marijuana. I just wouldn't know.
Okay, if you sub a negative x in, you should get the original function back. Same thing as what we just, what did we just do?
Yeah, well, let's just sit on the line.
Okay, so which one is that the same as that we just did? Which symmetry? Sub a negative x in, get the original function back. Y-axis symmetry. Even functions are the same things as y-axis symmetry. I want a better color though.
So odd functions are origin.
Okay, Luke's theory is that odd functions have origin symmetry.
What's that saying? Get what?
Sub in at negative x, get original function back. Okay, now this is what you're going to think is weird. When you test for an odd function, you still sub in a negative x. But, obviously you don't get the same thing back, huh? You get a negative of your original function back. In other words, all your signs are different when you get it back. Okay, you got to see that one happen, I know. That one's not quite so. So, you sub in negative x. Get a negative of the function back. Well, let me have you think about that a second. F of x is the same thing as what?
Y.
F of x is the same thing as writing y equals. So this is saying put in a negative x, get a negative y. Which kind of symmetry had a negative x and a negative y? So yes, Luke was having insight there, and yes, odd functions have origin symmetry.
Yay, Luke was right.
Yeah, I always think that one's easy to remember. They both start with O. Odd functions have origin symmetry. They both start with O.
15
You're
minutes.
at 15.
15 minutes.
Thanks, okay, we'll